Okay, good afternoon, everybody. I have already taken your first lecture on general physical chemistry on 15 July, but I cannot provide you the recorded lecture because some software issue. Screen is not properly recorded. That's why today I am going to record this lecture again, and I will upload this video in your corresponding Facebook group. Okay, so topic of today lecture, that is basically the repeated lecture of the first one, is general physical chemistry. So our first question is about percentage composition of oxygen in H2SO4. How can we calculate percentage composition of a particular atom in a particular compound? There are very simple formula. Percentage composition is basically mass of that quantity in the compound divided by mass of the compound into 100. Okay. So here we all know that there are 4 oxygen atoms and the atomic mass of oxygen is 16. So there are 4 oxygen atoms. So 16 into 4 divided by mass of the compound. Okay, so total mass of the compound will be atomic mass of hydrogen 1, sulfur 32. So there are 2 hydrogen atoms. So 2 into 1 plus sulfur 32 and 4 oxygen. Atomic mass of oxygen is 16. So 16 into 4 into 100. So answer will be 65. Okay, 60, that is exactly not 65, 65.25. Okay. $65.25. I am just checking one time sound is almost clear or not. Okay. Now sound ঠিক আছে. Okay. So our next question was percentage composition of water in magnesium sulfate 7H2O. So here we have to calculate the percentage composition of the water. So according to the formula, mass of that quantity in the compound. So we have to calculate total mass of the water. Okay. So water, we know molecular weight is 18. For hydrogen, atomic mass 2 as 1, and there are 2 hydrogen atoms, so 2 into 1, and oxygen 16. So basically molecular mass or molecular weight of H2 is 18. There are 7 H2 molecules, so into 7 divided by total mass of the compound. So magnesium 24, sulfur 32, there are 4 oxygen atoms, so 16 into 4, and 7 H2O, that is 7 into 18 into 100. So your answer will be 51.25. That's why we can calculate percentage composition of a atom or molecule in a particular compound. Okay. Our second question is about a compound has a molecular weight 90 and its empirical formula is CHO2. Find out molecular formula. So this question is about empirical formula and molecular formula. So at first we have to know what is empirical formula and what is molecular formula and what is the relation between these two. Okay. So basically empirical formula is the simplest ratio of atoms in whole number. Let's take an example. Just a moment. Yeah. C2H6. Okay, ethane. So here number of carbon atom is 2 and hydrogen atom is 6. So what is the ratio of atom of carbon and hydrogen? There are 2:6. If I simplify this one, then we will get 1:3. Okay, so this ratio is the simplest ratio and it will be taken in empirical formula. So the empirical formula is C1H3. Okay, similarly in case of glucose, C6H12O6. So there are atom ratio of carbon, hydrogen and oxygen is 6. There are 12 hydrogen and 6 oxygen. So 6:12:6. So the simplest ratio will be 1:2:1. So the empirical formula will be 1 carbon, 2 hydrogen and 1 oxygen, CH2O. Okay, so this is the empirical formula. So what is the relation between these two? Molecular formula equals to n into empirical formula, where n is an integer number. It can be 1, 2, 3, 4 and so on. It's not be a fraction. It is a positive quantity and integer number. Okay, and another relation between these two is n equals to molecular weight divided by empirical weight. Okay, so using these two formula we can easily calculate it, empirical formula or molecular formula or related problem we can be solved easily. Okay, so now I am moving to the problem. A compound has a molecular weight 90, empirical formula is CHO2. So empirical weight will be for carbon 12, for hydrogen 1 and there are 2 oxygen atom. For 1 oxygen, atomic mass 16, there are 2 oxygen, so 16 into 2, and if you calculate it you will get 45. So according to the formula, this n will be molecular weight divided by empirical weight. Molecular weight is already given to you, that is 90, divided by empirical weight, that is 45, that you have already calculated. So 90 by 45 equals to 2. So your n value is 2. If this value is not 2, suppose 1.98 or 1.9, so we can assume them as 2 because in this formula n is a positive integer. So molecular formula will equals to n into empirical formula. Our empirical formula has been already given to you, CHO2, and n value is 2. So just multiply this value with the corresponding stoichiometry. So C2, 2 into 1, 2, H, 2 into 1, 2, and in case of oxygen, 2 into 2 equals to 4. So C2H2O4. This is your molecular formula and the simplest ratio of this is CHO2. This is your empirical formula. Okay. This is a one type of question that can be from corresponding competitive exam. The next question is, a compound with carbon 40%, hydrogen 6.7%, oxygen 53.3%. Molecular weight of the compound is 60. Find out molecular formula. Okay, this is another type of question where basically percentage composition has been given to you. So at first we have to know how to approach this type of question. So at first some column can be drawn like element, percentage by weight composition, percentage by weight, atomic ratio, that is basically the mole ratio, and simplest ratio. Okay, so there are 3 type of elements: carbon, hydrogen and oxygen. So I at first write this one: carbon, hydrogen and oxygen. Percentage by weight, it is 40%, so 40. In case of hydrogen 6.7, in case of oxygen 53.3. Okay, atomic weight of carbon is 12, atomic weight of hydrogen 1 and atomic weight of oxygen is 16. Then we calculated atomic ratio, that is basically mole ratio, because if I am talking about methane, so one methane contain 1 carbon atom and 4 hydrogen atom. Okay, if I am considering 1 mole methane, so there will be basically number of carbon atoms 1 into Avogadro number and number of hydrogen atom 4 into Avogadro number. Okay, so if I will take ratio, then Avogadro number will be cancelled out from both the side and we will get 1:4. So atomic ratio and the molar ratio will be same. Okay. So how can we calculate atomic ratio? That is percentage by weight divided by atomic weight. So 40 divided by 12 equals to 3.3. 6.7 divided by 1, that is 6.7, and 53.3 divided by 16, that is 3.3. Okay, so ratio has been founded, but the problem is this is not the simplest ratio, this is a fraction. Okay, that's why we can take the smallest value between these three. So 3.3 is the smallest value, so we can divide both the term by the smallest value. So if I divide by 3.3, then it will be 1. 3.3 divided by 3.3, 1. 6.7 divided by 3.3 equals to 2, and 3.3 divided by 3.3 equals to 1. So 1 is to 2 is to 1. You can say this is the simplest ratio, but this is not the simplest ratio. Okay, so 1 is to 2 is to 1 is your simplest ratio. So what will be the empirical formula? 1 carbon, 2 hydrogen, and 1 oxygen from the simplest ratio. 1 carbon, 2 hydrogen, and 1 oxygen. So empirical formula will be CH2O. Now N equals to molecular weight divided by empirical formula. So empirical weight, sorry. So molecular weight is given to you 60, and empirical weight now you can easily calculate it because your empirical formula already present towards you. So carbon 12, hydrogen 1, and there are 2 hydrogen, so 2 is 2 into 1, and there are 1 oxygen. So atomic mass 16. Okay, so this value is 60 divided by 30, so this value is 2. So N value is 2. So molecular formula equals to N into empirical formula. Your empirical formula is CH2O into N, that is 2. So you have to multiply these 2 with the stoichiometry. So 2 into 1, 2, 2 into 2, 4, and 2 into 1, 2. So your molecular formula will be C2H4O2. Okay. Another type of question. One kind of similarity present between the previous one and this one. Thus here percentage composition is not given to you, just in only the mass is given to you. It's okay, no issue. Carbon 4.8 gram, hydrogen 1 gram, find empirical formula, and molecular weight is given to you, that is 60. Okay, so your element is carbon and hydrogen, and your weight or mass is 4.8 for carbon and 1 for hydrogen. So your atomic weight for carbon is 12, for hydrogen is 1. So atomic ratio will be basically molar ratio. So 4.8 divided by 12 equals to 0.4, and 1 by 1 equals to 1. But this is not the simplest ratio because it's a fraction. So now 0.4 is the smallest value between these two. That's why we have to divide 0.4 by 0.4 each quantity. Okay. So 0.4 divided by 0.4 equals to 1, and 1 by 0.4 equals to 2.5. But here after dividation, the 1 is to 2.5. This is not the simplest ratio. Okay, so the minimum quantity that can we multiply with this value to get simplest ratio. Okay, if I multiply by 1, 2.5 into 1, basically 2.5. This is a fraction. If I multiply by 2, then 2.5 into 2 equals to 5. That can be taken. Now in a ratio, if I multiply by something in a term, then we have to multiply by the same quantity in the another term. Okay, so basically we do nothing. So if I multiply 2.5 by 2, then we have to multiply this one value into 2. So you will get this value is 2 and this value is 5. So simplest ratio will be C2H5. There are 2 carbon and 5 hydrogen. Empirical formula is C2H5. Okay, so N value will be molecular weight divided by empirical weight. Molecular weight is 60 divided by empirical weight. There are 2 carbon, 12 into 2, 24, and there are 5 hydrogen. Atomic mass of hydrogen 1, so 1 into 5, that is basically 29. This value is 29. If I add this one, this value is 29. It is approximate 2. It is approximate 2. Okay, so n value is approximate 2. So molecular weight equals to n into empirical weight. Molecular formula equals to n into empirical formula. So there your empirical formula is C2H5. Then you have to multiply by 2. So it will be C4. 2 into 2 means 4, and 5 into 2 10. So your molecular formula will be C4H10. Okay, and your empirical formula will be C2H5. Next question. Find out number of moles in 32 gram of methane. Okay. Just a minute, I have just check one times it is completely recorded or not. Okay, okay, it is recorded. Fine, no issue. Okay. The next question, find out number of moles in 32 gram of methane. Very easy question. Moles means mass by molar mass. Just a minute. Okay. So mole means mass by molar mass. So find out the number of moles of 32 gram methane. So mass of the methane is given to you 32 gram, and you have to calculate molar mass of the methane. Carbon is 12 and there are 4 hydrogen, so 1:4 at a gram per mole, and you will calculate it and you will get 2 moles. Okay. The next question, find volume of 3 moles of carbon dioxide at STP. Okay. So at first you have to know the difference between STP and NTP. That is natural temperature pressure and standard temperature and pressure. In both the case, your standard pressure is 1 atm, but temperature is different. In case of NTP, this value is 25 degree centigrade room temperature, and in case of STP, this is 0 degree centigrade. Okay. So there are a very important formula that you have learned during your HS course. At STP, the volume of 1 mole any gases is 22.4 liter. Okay. If someone want to find out the corresponding volume as NTP, okay, no issue. There is pressure is constant. When pressure, we know when temperature is constant, we can use Boyle's law. Here pressure is constant, so we can use Charles' law. V1 by T1 equals to V2 by T2. Okay. So at STP, when volume is 22.4 and corresponding temperature 0 degree centigrade means 273 Kelvin, and in case of NTP, volume is unknown to you and your temperature is 25 plus 298 Kelvin. So if you write down this formula, V1 by T1 equals to V2 by T2, from this formula you can calculate at NTP the volume corresponds to 1 mole NES. Okay. So this 22.4 liter is basically at STP. Okay. So according to this formula, 1 mole of carbon, any gas, so carbon dioxide also a gas, so 1 mole carbon dioxide contain 22.4 liter. In your question 3 mole is given to you, so 1 mole corresponding to 22.4 liter, so 3 mole corresponds to 3 into 22.4, that is 67.2 liter. Okay. So this is very, very important, this concept. Next one. Yes, it's completely fine. Is it it is recording? Okay. I back to the PPT. Okay. The next question. If 16 gram of methane is burned, find how many gram of carbon dioxide is produced. Okay. So this is basically one kind of combustion reaction. So your hydrocarbon, methane is basically hydrocarbon, CH4, is react with aerial oxygen or burnt with oxygen, and you will get carbon dioxide and water. In case of combustion reaction, if you know the definition, 1 mole of the reactant react with excess oxygen to produce carbon dioxide and water. So your reactant is basically 1 mole. Okay. So in our reactant, to solve this type of question, at first you have to balance the equation. Okay. But carefully you can write this hydrocarbon, that is your reactant molecule, this must be 1 mole. Okay. So now I am going to balance this equation. There are 1 carbon atom, so there is 1 carbon atom is okay. There is 4 hydrogen atoms. So here there are basically 2 hydrogen atoms. So you have to multiply by 2. So if in water side I will write 2, then H will be 2 into 2 4, and in the left hand side H also 4. Now oxygen is not balanced. Here oxygen, there are 2 oxygen and there are 2 oxygen. That means there are 4 oxygen in the right hand side. To balance this, we have to multiply by 2 in the left hand side with the oxygen. So oxygen will be 4. Now this is a balanced equation. After balancing this equation, you have to proceed. Okay. So this balance equation, stoichiometric representation from this balance equation indicate that 1 mole of methane in the combustion reaction or burning with oxygen molecule gives 1 mole carbon dioxide. Okay. So 1 mole methane generate 1 mole carbon dioxide. So in your question 16 gram of methane is given to you. So at first we have to calculate what is the mole number corresponds to 16 gram methane. Okay. So how can we calculate mole number? As I discussed earlier, mole means mass by molar mass. Your 16 gram is given, so M is small is 16 and capital N for methane, there is atomic mass of carbon 12, atomic mass of hydrogen 1, so 12 plus 4 into 1. Okay, so this value will be nearly equals to 1 mole. So this 16 gram of methane is corresponds to 1 mole methane, and we know that 1 mole methane gives 1 mole carbon dioxide according to this balance equation. So 1 mole methane will give 1 mole carbon dioxide. But in our question, mole number is not the question. Our question is how many grams of carbon dioxide is produced. So we have to convert this mole number into gram. Very easy. You know that N equal to M by M, mass by molar mass. For carbon dioxide, you can calculate molar mass easily. That is 44 gram. For carbon 12, for oxygen 16. So there are 2 oxygens, so for 16 into 2, that will be 44 gram. Okay. So here capital M or molar mass is 44 gram, mole number is 1 mole. So what is the mass? 44 gram. It is a very simple. This is a 1 mole methane. So 1 mole methane corresponds to its molar mass, that is 44 gram. If the mole number is other than 1 moles, then you can calculate in this way. But here there are 1 mole. So 1 mole corresponds to its molecular mass or molar mass. So it will be equals to 44 gram of carbon dioxide. Okay? I think it's clear to you. It is clear to you. If 16 gram, this question, let's repeat. The next one is calcium carbonate on decomposition reaction after heating. It gives calcium oxide and carbon dioxide. Find out the volume of carbon dioxide produced when 50 gram of calcium carbonate is heated at STP. Very important question, very important. So at first we have to balance this equation. Here calcium 1 mole, carbon 1 mole, oxygen 2 plus 1, 3 mole, there are 3 moles. So this equation is already balanced. It's okay, very good. Find out the volume of carbon dioxide produced when 50 gram of calcium carbonate is heated at STP. Okay. So according to this equation, we can write 1 mole calcium carbonate produce 1 mole carbon dioxide. So 50 gram or 50 gram equals to molecular mass of calcium carbonate is 100. You can calculate in this way: calcium 40, carbon 12, or oxygen 16 into 3. Okay, so molar mass of calcium carbonate is 100 gram. So 50 gram calcium carbonate means if I calculate number of moles, so mass by molar mass 50 by 100, so half or 0.5 mole calcium carbonate. So very easy. 1 mole calcium carbonate will give 1 mole carbon dioxide. So half mole calcium carbonate will give half mole carbon dioxide. Now this incident occurs at STP, okay, and volume you have to calculate. So you know that at STP 1 mole for any gas 1 mole corresponding volume is 22.4 liter. So half mole corresponding volume is 22.4 divided by 2. So 11.2 liter. So your answer will be 11.2 liter. Okay. Next one. Find out mass of CO2 produced when 5.8 gram of butane is burnt. Butane, what is the molecular formula of butane? C4H10. So you burnt means you have to react this hydrocarbon with oxygen, excess oxygen. So C4H10 react with oxygen to produce carbon dioxide and water. Okay, it is a combustion reaction. So we take 1 mole C4H10, and to balance this equation, there are 4 carbon atoms. So I have multiplied by 4 with CO2, then carbon will be 4. And in case of hydrogen, there are 10 hydrogen atoms. But in case of water, there are 2 hydrogen atoms. That's why we multiply by 5. So H will be 10. Now the oxygen is in the right hand side. 4 into 2, that is 8. Or here in case of water, that is 5. The 8 plus 5 equals to 13. So in the right side, there are 13 oxygen atoms. So in the left side, we have to take 13 oxygen atoms. So there are 1 O2. So that's why we multiply by 13 by 2. So 13 by 2 into 2 equals to, that will be 13 oxygen atom. Okay. So this is your balanced equation. And in the question, carbon dioxide and butane is the matter of interest. So according to this stoichiometry equation, 1 mole butane will give 4 mole carbon dioxide. So 5.8 gram butane, similar way, you have to calculate the number of moles, 58 divided by the corresponding molar mass of the C4H10, and we will get 0.1 mole, just like previous. So 1 mole butane gives 4 mole CO2. So 0.1 mole butane gives 0.4 mole CO2. Okay. Now we have to calculate the mass. Mole equals to mass by molar mass. Your mole number is 0.4. Your molar mass of carbon dioxide is 44. You will get easily the mass of the carbon dioxide. Mole and mole inverse, 44 gram per mole. That is the unit of molar mass. So mole inverse will be cancelled out. Your answer will be in gram, 17.6 gram. Okay. These are some basic question, basic concept of physical chemistry. This question is also similar to it. Find out mass of oxygen required to produce 44.8 liter of carbon dioxide from C2H2 at STP. Okay. So in this case also, C2H2 is react with oxygen to produce carbon dioxide and water. At first we have to balance this equation. I have balanced this equation. So there are 2 carbon atoms in the left side. So we have multiplied by 2 with the carbon dioxide, and hydrogen is already 2. In the right hand side, hydrogen 2. In the oxygen, in case of oxygen, in the right hand side there are 2 into 2 plus 1, 5 oxygen. But here in the left side there are 1 oxygen molecule, basically 2 oxygen atom. That's why we multiply by 5 by 2. So in the left side there are 5 oxygen atom, and in the right side 5 oxygen atom. It is balanced. From this equation we can write here oxygen and carbon dioxide is topic of interest. Okay, so I am focusing on these two. 5 by 2 moles of O2 will give 2 mole of CO2. Okay, at STP we know that 22.4 liter corresponds to 1 mole any gas, here the carbon dioxide. So 22.4 liter corresponds to 1 mole CO2. So 44.8 liter corresponds to 2 mole CO2. That is equals to 2 mole CO2. Okay. So this 2, we know that this 2 mole CO2 is produced from 5 by 2 moles of oxygen. Okay. So 5 by 2 moles. So 5 by 2. Find out the mass of the oxygen required. Okay. this 2 mole of carbon dioxide, is produced from 5/2 moles of O2. So basically 44.8 liter CO2 produce করতে, or to form 44.8 liter CO2, basically 2 mole CO2, we have to need 5.2 mole O2. So now we have to calculate the mass corresponds to 5/2 mole O2. So mole equals to mass by molar mass. So here is the mole is 5/2, mass is unknown to us, and molar mass of O2 2 into 16. 6 is the atomic mass into 2. So mass will be 80 gram. Mass is basically 80 gram. Okay, chalo next. আমি মাঝে মাঝে একটু ভিডিওটা দেখে নিচ্ছি ঠিকঠাকভাবে রেকর্ড হচ্ছে কিনা। ওকে ওকে, ইটস ফাইন, ইটস ফাইন। Okay, the next question. Magnesium react with half oxygen to give magnesium oxide. If 2.4 gram magnesium is react with 3.2 gram oxygen, calculate the mass of magnesium oxide form. Okay, this is another type of question. To solve this type of question, we have to know about limiting reagent, the concept of limiting reagent. Okay. So between different type of reactant or reagent, which one is limiting reagent? There is a assumption that reaction is one directional and they proceed to completion. Okay. Between different type of reactant, the reactant which will be end at first, that is called limiting reagent. মানে reactant medium এ more than one reactant থাকতে পারে, কিন্তু যেটা আমার আগে শেষ হয়ে যাবে সেটাকে আমি বলবো লিমিটিং রিয়েজেন্ট। ওকে, সো বিটুইন ডিফারেন্ট টাইপ অফ রিয়েজেন্ট, দ্য রিয়েজেন্ট which will be end at first during reaction, it will called limiting reagent. Okay, so according to this stoichiometry equation, 2 moles A react with 3 mole B to gives 4 mole C and 1 mole D. Given number of moles of A is 3 mole and number of B is 4 moles, and number of moles of C have to calculate. Okay, so this is a basically unitary method. According to the stoichiometry equation, 2 mole A react with 3 mole B. So 2 mole A react with 3 mole B. So 1 mole A react with 3/2 mole of B. And according to our question, 3 mole of A given to us. So 3 mole of A react with 3/2 into 3 equals to 9/2, that is 4.5 mole B. Okay, that means as we use 3 mole of A according to this stoichiometry equation, for complete consumption of 3 mole of A, 4.5 mole of B is required. মানে 3 মোল A পুরোটাকে রিঅ্যাকশন করার জন্য 4.5 মোল B লাগবে। ওকে, for complete consumption of 3 mole A, 4.5 mole B is required. But according to our question, 4 mole B is given to you. So this is not sufficient to complete consumption of 3 mole of A. So that means when 4 mole B react with A, it must be is react with less than 3 mole of A. Complete 3 mole of A cannot be reacted. Very easy. We can understood in this way. 4.5 mole B react with 3 mole A. So 4 mole B react with 3/4.5 into 4. That is basically this value is 2.67. So this is less than 3. That means when B is completely consumed, then only 2.67 moles of A is consumed. So there are 3 minus 2.67 moles of A remain present in the solution as unreactant. This A cannot be reacted. This 3 minus 2.67 moles of A cannot be reacted because B is already all B are consumed. So during this case B is consumed at first, so B is our limiting reagent. So B is our limiting reagent. Okay. But during competitive exam, we cannot proceed in this way because it is a time consuming. So we can use a short trick, just like if I take these two reactant A and B, then we can calculate the ratio of number of mole of that particular reactant A is given to you divided by its stoichiometric coefficient in the balanced equation, and also the number of moles of B which is given to you divided by its stoichiometric coefficient in the balanced equation. According to our question, 3 moles of A is given to you, so 3 divided by stoichiometric coefficient of A is 2. Okay, so 3 divided by 2, this value is 1.5. And in case of B, the number of moles 4 is given to you divided by a stoichiometric coefficient. Here in this equation stoichiometric coefficient is 3, so 4 by 3, and this value is 1.33. Now between these two value, 1.33 is less than 1.5, so this value is less. So this value is less, so its corresponding reagent will be limiting reagent. So B will be limiting reagent. If this value is less than 1.33, then Na will be the limiting reagent. সো মধ্যে কথা হচ্ছে যে মোর দ্যান 1 যে ভ্যালুগুলো ক্যালকুলেট করছো রেশিও, তার মধ্যে যেটা কম তার কোরেসপন্ডিং রিয়েজেন্টটা হবে লিমিটিং রিয়েজেন্ট. ওকে, সো বিটুইন দিস টু রেশিও, ইন হুইচ কেস রেশিও ইজ মিনিমাম, the corresponding reactant will be the limiting reagent. So B is the limiting reagent. Now we are going to this question. Magnesium react with half oxygen to form magnesium oxide. If 2.4 gram magnesium is reacted with 3.2 gram oxygen, calculate the mass of magnesium oxide formed. Okay, so at first we have to calculate number of moles from this mass. So 2.4 gram magnesium means atomic mass of magnesium is 24, so 2.4 divided by 24 equals to 0.1 mole. In case of oxygen, 3.2 gram oxygen means 3.2 divided by its molecular mass, 2 into 16. Okay, so there is O2, not oxygen atom, there is O2, oxygen molecule, so 2 into 16, this value will be 0.1 mole. Okay, so in your stoichiometry equation, so at first we calculate this ratio magnesium and oxygen. In case of magnesium, your mole is 0.1 and stoichiometry 1, so 0.1 divided by 1. In case of oxygen, your mole number is 0.1, your stoichiometry is half, so 0.1 divided by half. So in case of magnesium, this value is 0.1, and in case of oxygen, this value is 0.2. As 0.1 is less than 0.2, so magnesium is your limiting reagent. So you have to calculate on the basis of magnesium, not on the basis of oxygen. Okay, so according to this equation, 1 mole magnesium will give 1 mole magnesium oxide. According to our question, 0.1 mole magnesium is given, so 0.1 mole magnesium will give 0.1 mole magnesium oxide. Okay, now you have to calculate just in the mass. So number of moles equals to mass by molar mass. So mole equals to 0.1 mole, and your mass of the corresponding magnesium oxide, magnesium 24, oxygen 16, so 24 plus 16 into 0.1, your answer will be 4 gram. Your answer will be 4 gram. Okay, okay, the next part is another term, percentage concentration. Okay, আমি একবার দেখে নি রেকর্ডিংটা ঠিকঠাক আসছে কিনা. ওকে, ফাইন. Okay, recording is okay. The next topic is percent concentration, very important. Basically we are interested normality, molarity, molality, about these terms. when we calculate solution or different type of concentration, when we calculate concentration of different solution. Okay, but there are some another concentration term, that is percent concentration, percentage weight by weight, volume by volume, and weight by volume. So we have to learn about this one also. Percent concentration means quantity of solute divided by quantity of solution. So it can be taken in mass, then it will be in the gram unit, and if it is taken in a volume, then it will be in the milliliter or ml unit into 100. Let's say percentage weight by weight, that means mass of the solute divided by mass of the solution. Okay, where mass of the solute is gram divided by mass of the solution in gram into 100. Okay, that means 1 gram solution contain how much gram of solute, that is your percentage W by W. Meaning percentage V by V mane, percentage V by V means volume of the solute in ml divided by volume of the solution in ml into 100. That means 100 ml solution contain how much ml of corresponding solute. So weight by weight, so mass by mass. In this case volume by volume, V by V. That's why a solute and solution is taken in volume unit, and the last one is percentage W by V, weight by volume. So your first one is for solute and the second one is for solution. So mass of the solute in gram divided by volume of the solution in ml into 100. What is the physical significance of it? 100 ml solution contain how much gram of solute molecule. It is known as percentage weight by volume. Okay. Let's say 10% W by W solution, which means 100 gram solution contain 10 gram solute. Volume percentage 10% V by V solution means 100 ml solution contain 10 ml solute. Okay, so how can we prepare this solution? 10 ml solute. So what is the, we know that solution equals to solute plus solvent. So in 100 ml solution there are 10 ml solute. So 100 minus 10, that is 90 ml of solvent. So if I mix 10 ml solute with 90 ml solvent, we will get a 10% V by V solution, volume by volume solution. Next one is 10% W by V solution. That means total volume of the solution is 100 ml and the mass of the solute is 10 gram. Now if I am talking about how to prepare this solution in your lab, this is the mass of the solute. This is not the volume of the solute. Okay, this is the mass of the solute, and this is the 100 ml is a volume of solution, not volume of the solvent. Student এই জায়গাটাতে কিন্তু ভুল করে, so very careful. This is the volume of the solution. This is not the volume of the solvent. So if you take 10 gram of solute, then 100 ml solvent is added to it. But this solution will not be 10% W by V. There will be some error because this 10 gram solute must contain some volume. So you can take in this way. If you take a 10 ml solute in a corresponding volumetric flux, 100 ml volumetric flux, then add water or other solvent up to the mark, or you take a measuring cylinder where mark is given to you, and 10 gram of solute is solute you added to it, and then add solvent up to the mark, but never add 100 ml solvent to this solution. Okay, because 100 ml is not the volume of the solvent here. This is the volume of the solution. That means solute plus solvent. Okay. The next question is from this topic. How to prepare 500 gram of 5% W by W solution. Okay, so you can use unitary method or this way. Unitary method means 100 gram with the W by W. That means 100 gram solution contain 5 gram solute. So 500 gram solution contain 5 into 5, 25 gram solute. Or you can calculate easily in this way. That is 500 into 5%. 500 into 5 by 100 equals to 25 gram solute. Total mass 500 gram. So mass of the solvent 500 minus 25, 475 gram. Okay. The next part, what is the concentration of solution, what is the concentration of the solution of percentage W by W when 2.5 gram NaCl dissolved is 150 ml of water, density of the water 1 gram per ml. Okay, so here water is your solvent, your mass of the solute, that is sodium chloride, is 2.5. okay, so what is the mass of the solution, what is the mass of the solution, how can we calculate it? Because we have to calculate percentage W by W, that means mass of the solute divided by mass of the solution. So mass of the solution we have to calculate at first. We know the mass of the solute. Now the volume of the solvent, that is water, is 150 ml. You all know that density of the water in CGS is 1 gram per cc or 1 gram per ml. Now the density equals to mass by volume. So mass equals to density into volume. Your density is 1 gram per ml, volume 150 ml. So ml will be cancelled out and mass of the solvent will be 150 gram. Okay. So your mass of the solute is 2.5 gram, mass of the solvent is 150 gram. So mass of the solution, solute plus solvent, it will be 2.5 plus 150. So 150 2.5 gram. Okay. And now you can calculate percentage W by W. So mass of the solute, that is 2.5 divided by mass of the solution 152.5 into 100. Your answer will be 1.639 or approximate 1.64. Okay. Next one. How to prepare 20 ml solution of 70% V by V? 70% V by V. Okay. So 100 ml solution content, 70 ml solute, 200 ml content, 70 into 2, 140 ml solute. Total volume 200 ml. So 140 ml ethanol. So 140 ml ethanol, and the rest part, that is 60 ml, will be the water. Okay, sanitizer 70% IPA, like 70% ethanol. Okay, how many grams of sodium hydroxide is required to prepare 2.5 liter solution of concentration 5% W by V? তাহলে 5% W by V means 100 ml solution contain 5 gram sodium hydroxide. Okay, so 2.5 liter. So at first you have to convert it milliliter. 2.5 into 10 to the power 3 ml solution contain 5 by 100 into 2.5 into 10 to the power 3, that is 125 gram of sodium hydroxide. Very easy question. Now I am moving to the next interesting concentration unit, that is normality. Normality, molarity, molality, these terms are very important for theoretical any exam purpose and during your laboratory experiment and also during your interview. So this concept is very, very important. So normality means number of gram equivalence of solute divided by volume of the solution. Okay, volume in liter. That means 1 liter solution contain how much gram equivalent of solute. This is known as normality. Okay, number of gram equivalent of solute divided by volume of the solution in liter. Now the question is, how can we calculate number of gram equivalent? If there is mole in spite of gram equivalent, then it is very easy to us, because we all know mole number equals to number of moles equals to mass by molar mass. Number of moles equals to mass by molar mass. So number of gram equivalent equals to gram mass by equivalent mass. This is just similar with respect to mass, moles. In case of moles, mass by molar mass, and in case of gram equivalent, mass by equivalent mass. Now the another question, how can we calculate equivalent mass? Equivalent mass equals to again molar mass divided by n factor. Molar mass divided by n factor. What is n factor? This n factor, the definition of the n factor is different for different type of pieces. If I am talking about acid, number of replaceable H plus ion in the solution indicating N factor. Like HCl, HCl in the solution give 1 H plus and 1 Cl minus, 1 HCl, okay. So here N factor is 1. But if I am talking about H2SO4, it will give 2 H plus and SO4 2 minus. So there are 2 H plus ions. So N factor is 2. Similarly for acetic acid, acetate and H plus, 1 H plus ion. Okay. So that is N factor is 1. In case of base, number of replaceable OH minus ion represent the N factor. So in case of sodium hydroxide, it will give in the solution 1 OH minus, so N factor is 1. In case of baryta or barium hydroxide, it will give 2 OH minus, so N factor is 2. And in case of electrolyte, it is different. In case of electrolyte, N factor is total number of positive charge or total number of negative charge or with its mod value. Okay, N factor is a positive quantity. So in case of electrolyte solution, in case of salt solution, total number of positive charge and total number of negative charge is balanced. Basically, this is called condition of electrical neutrality. Okay, so total number of positive charge and total number of negative charge will be same, but as N factor is a positive quantity, so if we take the total negative charge, then we have to add a mod value, that is we get a positive value. For example, in case of aluminum chloride, there are 1 aluminum 3 plus ion and 3 Cl minus ion. So 1 aluminum 3 plus ion contain plus 3 charge. There are 1 aluminum 3 plus, so 1 into 3, so basically plus 3. And if I calculate with respect to chloride ion, so 1 chloride ion contain charge minus 1, there are 3 chloride ion, 3 into minus 1, that is minus 3. But N factor cannot be negative, so we have to take a mod value. Mod of minus 3 equals to plus 3. So in this way, we can calculate N factor for acid, base or electrolyte. Now a question about normality. If 0.98 gram of sulfuric acid are present in 50 ml solution, what is the normality? Just we can use the formula. Normality equals to number of gram equivalent of sulfuric acid by volume of the solution. Gram equivalent means mass by equivalent mass, and equivalent mass means molar mass divided by N factor. So if I simplify this equation, we will get mass by molar mass into N factor by volume of the solution. Your mass is given to you 0.98 gram. So molar mass of the sulfuric acid is 98. 2 into 1 for sulfur 32, for oxygen 16 into 4 to 98. So 0.98 divided by 98. N factor value is 2. Here N factor value is 2. And volume of the solution is in liter, that is 500 ml. If I convert this value 500 into 10 to the power minus 3 liter, and after calculation you will get 0.04 normal. Okay. Okay. Now that question about normality of a mixture. Okay, আমি আরেকবার দেখে নিই রেকর্ডিংটা ঠিকঠাক হচ্ছে কিনা. Okay, it's fine. Normality of a mixture. Suppose we take two acid solution. Okay, the first one where normality is N1 and corresponding volume is V1, and another solution where concentration normality is N2 and volume is V2. These two can be both acid or both can be base. Okay, and then we mix these two solution. So if I take as ideal solution, then final volume will be the summation of these two. But in case of non-ideal solution, this volume cannot be equal to the corresponding total volume of V1 and V2. That I will explain you in detail in my next class. Okay. So now in this case, we just consider an ideal solution where basically final volume will be the volume correspond to these two, V1 plus V2. And if I write the normality, suppose N of this solution, then what is the final concentration in normality of this mixture. Okay, so normality means in this final solution, number of gram equivalent divided by volume of the solution. So total volume of the solution V1 plus V2, and gram equivalent, how can we calculate? Normality equals to gram equivalent by volume. So gum equivalent equals to normality into volume. So there are N1 into V1, that is for this portion, and N2 into V2, that is for this solution. Simple, just your formula. Normality equals to gum equivalent by volume. So gum equivalent equals to normality into volume. So N1 into V1, normality into volume, and N2 into V2, that is the total gum equivalent of the solute present in this mixture divided by total volume of the mixture. So N1 V1 plus N2 V2 divided by V1 plus V2. This is the normality of the final mixture. Okay. Now you can say, if these two solution, one is acid and another is base, then what will be the result? In this example, we can say both are acid and both are base in our previous example. But in this particular example, now I am taking one is acid, another is base. So you know that when acid react with base, neutralization reaction take place. So if the number of gum equivalent of acid, that is Na into Va, where the small a represent acid, small b represent base. So Na into Va is the number of gum equivalent of the acid, and NbVb is the corresponding the base. So it is the number of gum equivalent of the base. So if NaVa is greater than NbVb, so in the reaction medium some H plus will be remain and resulting solution will be acidic, and your normality of the final solution will be NaVa minus NbVb, that means get larger minus smaller divided by total volume Va plus Vb. If number of gum equivalent of acid is less than number of gum equivalent of base, so resulting solution will be basic, and the normality will be here also larger minus smaller. So NbVb minus NaVa divided by Va plus Vb. And if both the number of gum equivalent are same, this is basically a neutralization reaction. All acid are neutralized by the base. There will be no acid remain in the medium, or no base will be remain in the medium. All H plus and OH minus are consumed. Okay. The second part is molarity. Another important term. Molarity means number of moles of the solute divided by volume of the solution in liter. Okay. So that means 1 liter solution contain how much moles of solute. In case of normality, there are present how much gum equivalent of solute, but in case of molarity, how much mole of the solute. Okay. So there is a relation between normality and molarity. Normality equals to n factor into molarity. So if molarity is given to you, you can easily calculate normality. The question, find out the molarity of 0.2 normal H2SO4. So 0.2 in case of sulfuric acid, if we break this one, 2H plus and SO4 2 minus, so there are 2H plus ion, so n factor is 2 into molarity, so your molarity is 0.1. If someone asks me what will be the greater, normality or molarity, that depends. This depends on the n factor. If n factor is 1, normality equals to molarity. Okay. If n factor is greater than 1, so normality equals to 2 into molarity. It can be 2 into molarity, 3 into molarity. So it is normality is greater than molarity. Okay. So depending on the condition of, depending on the value of normality, it can be equal or greater than molarity. Okay. Find the molarity of 0.2 molar H2SO4. Oh, similar. That is very. I think that is the just previous one. Yes. This question is important question. This question is also important. 100 ml 0.1 molar sulfuric acid. If you have to prepare 100 ml 0.1 molar sulfuric acid, then how much mass of sulfuric acid is have to taken? So according to formula, 0.1 molar equals to number of moles of sulfuric acid divided by volume of the solution in liter. Okay, this mole number is not given to us. Volume 100 ml, so 100 into 10 to the power minus 3 liter. Okay, so your mole number of the sulfuric acid is basically 0.01 mole. You just calculate it. Now mole equals to mass by molar mass. In case of sulfuric acid, molar mass 98 gram per liter. Mole number is 0.01, so mass will be 0.98 gram. Okay, so the mass of the given sulfuric acid is 0.98 gram. The last term is molality. Molality means this is difference. These are different term from normality and molarity. In both the case, volume of the solution is taken, but in here mass of the solvent is taken. The definition is just like 1 kg solvent containing how much moles of solute. Okay, your molarity is represented by capital M, but this molality is represented by small m. In both the case, number of moles of solute, but difference is in the denominator. In case of molarity, volume of the solution in liter is given, and in case of molality, mass of the solvent in kg is given. So definition of the molality is number of moles of solute present in 1 kg solvent. Okay, so there is a question, find molality of 20 gram sodium hydroxide dissolved in 100 gram solution. So molality equals to mass, at first we have to calculate moles of solute. 20 gram sodium hydroxide molar mass, sodium hydroxide molar mass 23 plus 16 plus 1. Okay, so that is basically sodium hydroxide মানে 40. So 20 by 40 mass by molar mass, that will be the mole number of sodium hydroxide divided by volume of the solution. 100 gram solution, so divided by mass of the solvent. So 20 gram is the mass of the solute, 100 gram is the mass of the solution. The mass of the solvent will be 100 minus 20, 100 minus 20, that is 80 mass of the solvent, but this is in gram unit, but according to our formula we have to take it in kg. So that's why 80 into 10 to the power minus 3. So this is the mass of the solvent in kg, and the above part of is the number of moles of the solute. You can easily calculate molality. There are two homework for you. How many grams of oxalic acid have to taken to prepare 100 ml 0.1 normal oxalic acid? The molecular formula is oxalic acid is given to you. Oxalic acid is diprotic acid, and you have to calculate 2H2O also. This is the water of crystallization. So molecular weight of oxalic acid is not 90 plus 2 into 18, that is 36. So molecular weight is 126. That's why I am written here the exact molecular formula of the oxalic acid. So you can easily find out the number of grams of oxalic acid. So if you, I think you will done it. And if there is some problem, so then I can discuss in my next class. Okay. The next question is, how many grams of K2Cr2O7 is required to prepare 100 ml N by 10 K2Cr2O7 solution? Similar question. Okay. Just you put the formula properly and you have to find out number of grams. And the last question that was of my previous class, find the molarity of 98% W by W weight by weight sulfuric acid solution, and the specific gravity 1.8 gram per ml. Specific gravity is given to you. It is basically density of the solution. Okay, so 100 gram solution, the 98% W by W means 100 gram solution contain 98 gram sulfuric acid, and we know the molecular weight of the sulfuric acid is 98. So 98 gram sulfuric acid means 1 mole sulfuric acid. 1 mole sulfuric acid. Now density equals to mass by volume. Density equals to mass by volume. So volume of the solution equals to mass by density. Mass is mass of the solution 100 gram, and density is 1.8 gram per ml. So it will be 100 by 1.8 into now this ml can be calculated, converted into liter, because in our formula molarity liter is given to us. So this ml value 100 by 1.8 ml into 10 to the power minus 3, that will be the liter. That is the volume of the solution. So mole number of the solute is 1 mole divided by volume of the solution in liter. 100 by 1.8 into 10 to the power minus 3. If you calculate it, it will get 18 molar. It will be at 18 molar. So from weight by weight type of percent concentration to molarity can be calculated in this way. Okay. So in my previous class, I have discussed up to this one, and in my next class I am going to the another interesting portion, that is solution, where we again discuss about vapor pressure, concept of vapor pressure for different type of solution, different type of electrolyte, volatile, non-volatile. Okay, different type of qualitative properties like elevation of boiling point, depression of freezing point, lowering of vapor pressure, osmotic pressure, all can be discussed, all will be discussed in our next lecture. Okay, so just a minute. So this was is about first lecture. Now this video will be saved in your corresponding Facebook group, and you can get this video easily at any time during your course. Okay, or if যারা নতুন এখানে জয়েন করেছো, যদি কোনো রকম কিছু প্রবলেম থাকে, কোনো জায়গায় যদি কিছু বোঝার কোনো প্রবলেম থেকে থাকে, তাহলে তারা অবশ্যই আমার থেকে জেনে নিও, গ্রুপে জানাতে পারো, ইনবক্স করতে পারো, যদি কোনো রকম কিছু ডাউট থাকে জেনে নিও। অ্যান্ড if there are any doubts or problems regarding to the class or any concept, please feel free to discuss with me, no issue, in the group or inbox. And there are some question about the solution which will be discussed in my next class, so I am just talking you, you can follow your HS level book, any book, it's maybe the student who which are belongs from West Bengal book, you can follow Chaya publication, or other board you can follow NCERT, and so just read this chapter properly in your HS level. Okay, so this solution, read this chapter just one times for your revision purpose, then you can try to solve this question of this assignment. Okay, so this assignment is basically consists of two parts. One is general physical chemistry and next part is solution. So first part I have already covered, and the second part, that is the solution, I will discuss in my next class. So I hope you will try the rest question. Okay, thank you so much.